So we're going to talk about function operations. We're going to do addition, subtraction, multiplication. We're going to run through those quickly because we've really already done those. Composition's what I really want to focus on today. So, yes, we're starting now. The difference is, just like with the exponent properties, the only difference is we're dealing with fractions now instead of whole numbers. So, maybe I have something like 2x to the 1/2 minus 6x to the 1/4. And I'm going to call that f of x. And remember, that's the same thing as y equals. It's just a way to name the function, okay? And maybe I call g of x, maybe I say g of x is 3x to the 1/2 plus 6. Okay? All right, tell me when you're ready. So when I add, remember, because the way they're going to do it in your homework is they're going to define f of x and g of x. And then they're going to come say, now what is f of x plus g of x?
What?
I was about to say, oh my gosh, Brady. Okay, so remember when we're adding, we're looking for like terms to combine, right? So tell me, remind me, what are like terms?
Like 3 times it or 3x?
Add. Tell me what like terms are, though. Not an example, but define it for me. They have to have the same what? Same base or variable, right? And same what?
Root.
Exponent. Let me say exponent. Okay. So if I'm looking at f and g here, which ones? Oh no. The 2 and the 3, you're absolutely right. So if I do f of x plus g of x, that means I'm doing 2x to the 1/2. Not that. Minus 6x to the 1/4. And to that, I'm going to add g, which is 3x 1/2 plus 6. And Bryce says that the like terms, I'm adding f and g.
Wrote it down.
I just wrote it. F is this,
Oh.
g is that. So you told me these two are the only like terms.
Half.
So whenever I combine them, I add the numbers in front and I keep the variable and the exponent the same, right? Okay. Nothing else is like terms, so I just write it, okay? If you can't combine it, write it. So minus 6x to the 1/4 plus 6, and I'm done.
Equals 0?
It don't equal anything, we're just combining.
So just combine.
We're not solving right
Switch it
now.
up now. You gotta
I ain't switching it up.
You never switch up.
Okay.
Never change them again.
Brady, you are killing me. Killing me. All right. That's addition. Now subtraction. Let's use this same f and g. F of x, what was f of x again? 2x, 1/2, 6x, 1/4. And what was g? All right, so this time when I'm subtracting, and here's where y'all kind of got confused when we did polynomials. If I subtract, I have to make sure that I am subtracting everything that follows that minus sign right there. Okay, so this is where we did the same change. Let me finish writing this and I'll stop for a minute. Change everything. What I'm going to do, if I want to do f of x minus g of x, that means I want to take all of this, 2x to the 1/2 plus 6x to the 1/4, and I want to subtract, and I'm going to put them in parentheses so you can see the difference here. 3x, oh, that's supposed to be a 1/2 there, to the 1/2 plus 6. So what I have to do, because I'm subtracting everything in g. Yep. Keep this the same, change this, and change this.
Hold up.
Okay? Now, okay. Now combine your like terms.
Yeah, there is. You got to add. No.
Is there?
2 plus -3 is
That's right.
-1.
That's right. Anything else that are like terms?
Nope.
Nope. -6 or plus -6. You change that.
Plus 6x.
There ain't no x. Oh no, 6. Oh, you talking about to the 1/4?
Well, that's all we got to do for
X 1/4.
Yes. 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 I thought you were talking about 6. Okay. Addition, subtraction, easy. Yeah. Go ahead.
That's all we did for like addition.
Yes.
Alright, so we done with
No.
that. Man, come on, buddy.
All right. Multiplication. Now, just as a review, when we said when we add like terms, we combine the coefficient, we leave the exponent alone, right? But when we multiply, we have to multiply the coefficients. And what do we do with the exponents? If you're multiplying, if you're add them.
Oh hell. Heck. That's the number in front of the next one.
Yep. Number in front of the variable.
Alright, don't go no further.
I'm not. I'm gonna pause. Multiplication. Let's say f of x. I'm gonna change f and x and g of x a little bit. I'm gonna call f of x 3x to the 1/2 plus 4, and I'm gonna call g of x 7x. Now, when I multiply, if I do f of x times g of x, you got to remember whenever we're multiplying, we're having to distribute if it has more than one part. So I got 3x to the 1/2 plus 4 times 7x. Okay. So I'm going to move this around a little bit so it's a little bit more familiar to us because we can multiply in any order that we want. I'm going to do 7x times 3x to the 1/2 plus 4. So you can see that 7 distributing through.
What?
I just switched the order they were in because I'm going to distribute that 7x through. All right.
So you get 21x.
Yep. All right, so remember what we do when we multiply. We multiply coefficients, so 7 times 3 is 21, and we add exponents. Now the difference is I have fraction exponents now, not just whole numbers. So what is 1 plus 1/2 as a fraction?
I thought you got 2.
What?
3/2.
3 over 2. What'd you say, Bryce?
I thought you had 2.
Had 2 what?
You had 2. 1 plus 3x.
So if we're in the exponent there, there's a 1.
If this was just an x1, but that's an x1/2. So I have to do 1 plus 1/2. You with me?
So if it was 1 and 1/2.
That's 3 over 2.
Hey, so there's not an exponent there, the
What?
number is 1.
If there's not an exponent, there's 1. Yeah. 1 plus 1/2 is 3 over 2. Because this is like 2 over 2 plus 1 over 2.
Yeah, but I'm saying I thought that was 2 and not 1.
You thought what was 2?
7x times 3x, 21x squared, which means it's going to be a 2 at the top.
You can't. No, you can't because you have to add 1/2 and 1. You can't add 1 and 1 because when you add something to a fraction, you.
Supposed to be 2. 2 plus 1/2 is what I'm trying to say.
What? Right, where did you get it wrong?
No, if the
7x times 3x is 21x squared.
right, but that's not 3x. That's 3x to the 1/2.
Yeah, somebody's with.
No, we used
Yeah, we don't matter what happened to it. Yeah, what happened to the fraction in the top?
We still are adding. It's just different exponents now.
I see what he's saying.
I don't.
Look, man. I ain't.
Look, Now let's distribute to the second piece.
What? Oh.
7x times 4.
28x. That's your answer.
That's your answer.
Alright.
Alright.
So if you add and subtract this effectively, so you have to do the function.
Division, and then I'm going to stop. I'm going to save composition for tomorrow.
What is the composition?
You might as well go ahead and get that out.
Composition's not as easy as
No, don't do it today.
No.
You have any questions?
Do it.
All right, division. We haven't even done division yet, and y'all are like, do it, do it. All right, let's say f of x is 6x. G of x is x to the 3/4. Now, remember when we multiplied, we combined, we multiplied coefficients, we added exponents. When we divide, we have to simplify fractions, okay, because we're talking about dividing in a fraction, and we have to subtract exponents. So if I do f of x divided by g of x, f of x is 6x, g of x is x to the 3/4. I can't simplify 6 over 1 any simpler than that, so I leave that. But I do need to subtract the exponents on the x. This is an imaginary what? 1. So if I subtract 1 minus 3/4, what do I get? 1/4. And I'm done. If it's negative, you need to put it back in the bottom and make it positive. Yep, yep. Take the same one and let's flip it around. So let's do g of x over f of x. That'll give us a negative. Okay. So I'm going to take x to the 3/4 over 6x. So now what is 3/4 minus 1? Negative 1/4. So anytime you subtract, you stay up top. The 6 is still down in the bottom. But I can't have a negative exponent. So anytime I have a negative exponent, I make it positive and I move it. So I'm going to make it positive, move it down here with the 6, but there's nothing up top left. So I need to put a what there? A 1. So I'll have 1 over 6x to the 1/4. That's all you do.